In part A, we are given 2 points that sit on a line, one at 4, 5, and one at 12, minus 1. And we're asked to give a formula for this linear function that passes through these points, both in point-slope form and in the slope-intercept form. And so let's just recall what those forms look like. The point-slope form in general, this can be written in the form y minus y0 equals m times x minus x0. Okay, where here m denotes the slope, and we know that the point with coordinates x0, y0 is 1 point on that line. The slope-intercept form in general looks like y is equal to mx plus b. Okay, where here the slope is m, so both of the, whichever way we write it, we should have the same slope in part A, and b here denotes the y-intercept. Okay, so in part A, let's just be careful how we identify the x and y values. So we have a point at 4, 5, and we can call this our x0, y0. And we have a second point at 12 minus 1, and we can call this our x1, y1. So in either case, we're going to need the slope of this line, and it's going to be the same whichever form we write it in. So the slope is equal to the change in y over the change in x. Okay, so we want to be careful that we set up the difference in y values on top and the difference in x values on the bottom. So these triangles represent change in y, change in x. And so when we calculate these changes, we need to do them consistently in the sense that I take y1 minus y0, and then I need to take x1 minus x0 on the bottom. So in this case, my y1 was minus 1, my y0 was 5, and my x1, therefore, I need to start with this value of x if on the top I started with this value of y. So now I have 12 is x1 minus x0, which is 4. So I get minus 6 over 8, and this gives me a slope if I reduce this to minus 3/4. Okay, so here's my slope. So now if I'm giving this in point slope form, I would have y minus y0, which is 5, is equal to m minus 3/4 x minus x0, which is 4. And here's one way to write out the point slope form. Okay, and it's not unique. For example, I could have chosen the other point at 12 minus 1, and this would have given me another way of writing this out in point slope form, for example, as y minus a minus 1, in other words, y plus 1 is equal to minus 3/4 x minus 12. Okay, so either of these forms would have been fine. So it doesn't matter which point you choose when you write out the point slope form. For slope-intercept form, I can now take either of these. So since I did this one, I'm going to use that for my point slope form, and I'm going to just simplify this equation, solve for y, and simplify. So distributing the minus 3/4 up here to both the x and the minus 4, this gives me minus 3/4 times x plus 3. Okay, and so when I multiply minus 3/4 times minus 4, these 4's cancel. The negatives give me a positive 3. And now I solve for y by adding 5 to both sides. So this would give me y is equal to minus 3/4 x plus 8 after adding 5 to both sides. Okay, and now this is a unique way of writing this. I can't, if I would have started with this form, point-slope form, and eventually simplified, I would have gotten the same slope-intercept form below. Okay, and now looking at the next one in part B, here we're given a graph. And so one way to find this formula, and here we just want the formula in slope-intercept form, would be to identify 2 points on this graph. Namely, here's an intercept. So the point at 0, 6, that's on the graph. We'll call that our x0, y0. And we have a second point on the graph that is pretty clear, which is 2, 0, the x-intercept, and we'll call that our x1, y1. And so now it is just the same as part A in that I have 2 points and I want to find the equation for a line that passes through those 2 points. So we can find the slope, which is the change in y over the change in x. So in this case, I can take my my y1 is 0, my y0 is 6, so I get 0 minus 6. The line has decreased by 6 units when I increased x by 2. So my x1 is 2 and my x0 is 0. So this gives me minus 6 over 2, and so I have a slope of minus 3. And to put this in slope-intercept form, if I know a point, if I know a slope and I know the y-intercept, well then we're ready to come up with a formula. And so here we see the y-intercept. We know that b is equal to 6, since that's my vertical intercept. So now once I know m and b, I have that y is equal to mx plus b. And there would be our slope-intercept form for b. And it's not a bad idea to check your answer in the end. So if, for example, I take and substitute 0 in for x, yes, my output is 6. When I take and substitute 2 in for x, my output would be 0. So that checks out. And we could have done this in part A. We could have done this check in part A as well, meaning I could take my point 4, 5, plug it into, say, the equation, the point-slope form that we had over here. So plugging 4 in for x and simplifying, we would see that, yes, y is equal to 5. Plugging 12 minus 1 in, so if I plug a 12 in for x and a minus 1 in for y, I would see I get the same value on each side. So that would have verified my answer. We could have taken these points and made sure that they satisfy the equation when we write it in slope-intercept form. So it's never a bad idea when we have time to check our work.